Hello, so in the next one we're going to explain about steel alloys. Alloy steels contain one or more alloying elements other than carbon that have been added in amounts exceeding a specified minimum to produce properties not available in carbon steel. So basically alloy steel is other than carbon elements being mixed in the steel carbon steel products to produce a specified properties. As we can see in the table here, the element being added and the properties it produces is shown here. As you added aluminium in the steel carbon steel products. Aluminium is a deoxidizer used to control the grain size within the structure of the steel, which promotes surface hardening. So you control the grain size within the structure of steel, so you can have a more shiny surface and a hardened surface. You can also add boron, which increases the depth of hardness. Carbon, as we mentioned earlier, carbon increases hardness and strength, but also contribute to brittleness. It reduces the ductility. Chromium is added to increase the hardness and also corrosion and wear resistance. So, as you may have heard before, steel with chrome is more resistance or more water resistance, more corrosion resistance and wear resistance. Other examples say titanium. As you have heard before, titanium is being added to the steel. It prevents intergranular corrosions of stainless steel, is a deoxidizer, and increases strength in low carbon steel. So as we know, carbon steels with low carbon has lower hardness. So by adding titanium, it increases the hardness, but at the same time it's a deoxidizer. So it's it resists the oxidation. It provides protection to the steel. You can go through this table to understand more on the elements being added to the steel to produce steel alloys. Next, which is more close to us, is the structures. So I would like to explain the structural steel that is available in the market. So basically, structural steel is produced in 3 strength grades: 43, 50, and 55. So structural steel is the type of steel products that are solely used for structural purposes. So mainly used, as name implies, it is for structural purposes. So that is why they are called structural steel. A building formed by steel structure is commonly known as steel structures that use steel framing structural system. So usually building being formed by steel using steel framing. It's not quite familiar here in Malaysia, but in US and during the early industrial age, at the early age during the at the early age of construction, they use mostly steel framing systems, such as the Empire State Building. They use the structural steel framing. So instead of most of the building in Malaysia, they use reinforced concrete, where we use concrete reinforced with steel. So a bridge can be constructed by steel in the form of girder of trusses. Now, I said this is commonly seen in Malaysia, especially in old bridges that convey trains, especially in Baling. I've seen one in Baling, so you might have seen one before in your hometown. So as we said earlier, you have a 3 grade of steel: 43, 50, and 55. So the grade of steel indicates the strength of steel, which is denoted by stress. So at grade 43, the maximum stress can sustain by the grade 43 is 275 Newton per millimeter square. 50 grade 50 can sustain 355, and 55 grade 55 can sustain up to 450. After the elastic limit here of 40, 450, 355 and 275, the steel will undergo plastic a plastic limit. So once the steel deform under plastic region here, plastic range, or is it called here, it will not return back to its original form. So the stress strain curves show a small plateau beyond elastic limit, and then an increase in strength due to strain hardening. So this is the region of strain hardening, where the steel does not increase the strength, but the strain is increasing at the same stress. So beyond this 450, it's still gonna deform, but at the same amount of stress applied, which is called the strain hardening. And plastic design is based on the horizontal part of the stress strain. So this is a plastic range. During the strain hardening, the steel will not return back to its original form. Steel sections. So that is the steel products for structural steel. And then we also have steel sections where we use a prefabricated section for our building. So basically the design of a building sometimes based on the steel sections can assist the designer in analysis of the building. So we have in steel section, we have rolled and formed sections, we have compound sections, we have build-up sections, and cold rolled sections. In rolled and formed section, basically you roll and then you form the sections. This is produced in steel mills from steel billets, as we mentioned earlier. Billets is smaller than blooms. By passing them through a series of rolls. Series of rolls. So you roll the steel in a heated section. That's why they call it a hot roll. So a heated steel section, a heated billets, is rolled through a roller to produce a rolled and formed sections. So we have basically 6 form of rolled and formed sections. We have universal beams. Efficient is in resisting bending moment about major axis. So we have a universal beam, which is in the form of universal beam, I beam. Sometimes they call it I beam. We have universal columns produced to resist axial load with a high radius of gyration. We have overturning at the end of column. So a universal column is best to resist this radius of gyration about minor axis to prevent buckling in that place. So sometimes they call it H column, but the more universal name is universal columns, universal beams, universal columns, or sometimes they call I beam, H column. So as mentioned earlier, so we have a gyration, radius of gyration here, a moment at the minor axis. So you have this beam, these sections, this flange, this web, if I'm not mistaken, this web to counteract the rotation on the minor axis, but on the major axis we have both column, both flange, both web. So channels used for beams, bracing members, truss members, and in compound members. Sometimes we have a combination, so they call it compound members. So we have channel here. Mostly we use for beams. Sometimes we can apply a hook here, so we can have a moving roller here, especially used in factory. So that is channels. Equals and unequals angles, we have weak, equal. So angle, we have a perfect angle here, and then equal refers to your elbow, whether it is equal or unequal angle. Structural T's refers to T, which is often used for beams, truss beams, truss members, and ties, and light beams. Structural T's. Sometimes they use I-beam, depends on your design. A circular, square, or rectangular hollow section produced from flat plate. The circular are made first, then reshaped into rectangular or square. So these are very efficient compression members, and also used for purlins, sheeting rails. So as we've learned before in the 151, the best column to prevent the best column to prevent the buckling. To prevent buckling is the circular shape, as you have a bigger moment of inertia to counteract the overturning moment.